Okay, so this is the outline for chapter 29. So in this chapter, we will learn first the magnetic field due to a current. Okay, how we can evaluate the B field generated by the current. Okay, actually it's about the Biot-Savart law. Biot-Savart law, and then we will also talk about the force between two parallel currents. Also, this is just an extension from the previous, the second version of the Lorentz force. Okay, so for that case, we have a current carrying wire in a perpendicular B field. Okay, so there is a force acting on it. So in here, as much as we know, if a current will also generate B field, so which means if we place two current close together, then one current will generate B field. So this B field will have force acting on the other current, okay, and vice versa. So there will be force between two parallel currents. And then we will talk about the Ampere's law. So it's already a long time that we have not mentioned anything about the Maxwell equation. So this is the second law we will learn in the Maxwell equation. So for the previous one, chapter 23, about the Gauss law. Of course, in between, I also mentioned a bit about the B field version of the Gauss law, but actually in the textbook it will be mentioned in chapter 33. So 32. So here is actually the second law in the Maxwell equation we'll learn. And then we'll talk about the solenoid and toroid. 就是一些线圈或者是一个圈掰成一个环这样。And then we'll also talk about the current carrying coil as a magnetic dipole， 就是它们是一个等效的东西，就是 magnetic dipole 跟 current carrying coil 是你可以把它看作是一个同样的东西，然后一个磁铁，一根磁铁，其实它也是一个 magnetic dipole moment。所以一个线圈，一个带电的线圈，有电流的线圈，跟一个一个 magnetic bar 就是一个磁铁。它们是等效的它们是等效的，它们都是一个 magnetic dipole moment， magnetic dipole Okay, so here we so this is the overview of the electromagnetism. So I just show it a bit. Today I didn't wear the T-shirt for the Maxwell equation. But here, so actually, in chapter 32, we will summarize the whole Maxwell equation, and actually in chapter 23, we have learned the Gauss law, and in this chapter we will learn Ampere's law, and we will also learn Faraday's law in the coming chapter, in chapter 30, and finally chapter 32, we will also mention this B field version of the Gauss law. So these two are similar, although the notation is different from these textbooks. I just show it a bit. And of course, even though here, okay, it should be a Q enclosed, but yeah, it's just so integration sign here. Okay, but of course we will make use of it later on. But I want to mention that for the B field version, we don't have the magnetic monopole, OK， 没有磁单极，所以这里右手边变成0，所以用起来会比较简单 ，OK。And actually in this textbook, we only learn we only learn the integration form. But actually, if actually if we really need to use Maxwell equation to calculate some E field, B field for some specific structure, then the point form or the differential form will be more useful. 这个就是它有积分形式跟微分形式，但是课本里面只有提到这个积分形式。微分形式的话，其实手算也不好算，但是如果你要用一些 computer 去算一些结构的话，那其实就不会用右手边的右手边的话，只是在考试里面有用的话，那真实如果要用电脑去计算的话，其实是左手边，因为比如说这里一个式子的话， 你一插出来的话，它就会变成三个偏微分方程啊，就是因为 b 的话是 x y z 哦，每个都是 x y z 方向，就是比如说你要解一些什么天线设计的哦，它产生什么场啊或者怎么样，那就是会用到这些 Maxwell equation 去计算。Okay, so here we first introduce the magnetic fields due to a current. Okay, so here we have a equation like this. Okay, so we have a dB. Okay, so this is not 就是这个不是分贝的，就是你把它变这个 d 是 derivative 那个 d， 这两个 d 都是 derivative。Okay, so here it says the magnitude of the field dB. Okay, so a small b field, okay, produced at point P at distance r by a current length element ds turns out to be something like this. Okay, so this is also a law. Okay, this is also a law called the law of Biot-Savart or Biot-Savart law. OK， 那我的看法是，这个跟库伦力是他们也是兄弟来的，就是 for Coulomb's force it is actually like F equals 1 over 4 pi epsilon naught and then times Q1 Q2 over R square. Okay, so you can see we have 4 pi here, we have mu naught, we have epsilon naught, we have R square, we have this one. This one is actually I cross ds. I cross ds. I cross or maybe I times something cross ds. Okay, ds cross r. I ds cross r hat. Okay, so we define another vector so that actually is a product. It's a product. Okay, this is also a product but a scalar product. So these two equations look very alike. These two look yeah. So here we try to understand this first by introducing the constant mu zero for the mu zero. Okay, so in the electrostatics electrostatics we have epsilon naught. Okay, epsilon naught as the permeability permittivity. Okay, for the B field we have mu zero. Okay, the mu zero is actually called the permeability. 那 epsilon naught 就是电导率，那这个 permeability constant 就是磁导率常数，磁导率，所以他们也是兄弟来的。Okay, so actually the mu zero is 4 pi times 10 to negative 7. 4 pi times 10 to negative 7. And then so like this. Usually I remember I just remember this one rather than 1.26 times 10 to negative 6. Yeah, because this 4 pi and this 4 pi cancel. So you already feel like, okay, why it has a 4 pi here. So just to make them look alike. 但是 epsilon naught 跟 mu naught 的话，它们通常是有个导数的，就是它在某个地方的电场的一个式子换成磁场的话，它就会变成 mu 1/0，这个在分母一个就跑到分子哦，这个如果在分子另外一个就跑到分母，它们就是不会在同一个位置。Okay, and then here I also mentioned this one. This constant is very, very important in physics. Okay, so actually this one is the speed of light. Okay, if you don't believe, you can try to substitute. Oh, this is 8.85 times 10 to negative 12. This one is 4 pi times 10 to negative 7. Okay, multiply them together and then take the square root. Okay, and then take the reciprocal. It becomes around 3 times 10 to the 8. Okay. This is 3 times or 2.998 times 10 to the 8th power meter per second. 这个就是真空里面的光速啊，真空里面的光速啊，就是因为光的话就是一种电磁波嘛，所以它就跟一些电跟磁的特性有关。这就是一个很 elegant 的式子。Okay, so if we like to write this one into a vector form, actually it will be like a dB vector equals mu 0 over 4 pi and then still r square and then I times ds cross r hat. Okay, so how do we understand this ds cross r hat? Okay, so here is the graph. Okay, so suppose we have a current. It is not a straight line, so in that case we need to separate this current into many segments. Okay, so for this one ds, okay, we have ds vector. Okay, so this ds vector is actually the tangent line. It's tangent line at this point and also follow the direction. Okay, for this tangent line, it can point to this way or the other way, but this way follow the direction of the current. Okay, so here we have I times ds to be this vector, and what is r or r hat? Okay, r will be starting from this ds and then pointing to the direction, pointing to the point P we concern. Okay, we would like to find the B field at this point only. Okay, so we try to connect this point to this point. Okay, so this is the r vector. So r hat is the unit vector, points to the same direction. 这个 r hat 就是21章有出现过类似的嘛，就是 r hat 就是一个单位向量的话就是指向这个方向，从你这个电流的那个小段啊，指向你关心的那个点的那个方向啊，然后取长度为1，就是这个 r hat。所以 so for this case, we should have I ds cross r hat. So we can also practice the right hand rule again. So you use your finger points to this direction and then cross to the right side. Your thumb is pointing into the page. So you can see here dB into the page like this. Okay, with a green cross here. Okay, so also this theta is between 0 and 180 degree. Okay, and actually this one is called the Biot-Savart law. Okay, so again, this is a law, so we are not able to prove it. So later on, we will also try to verify that, or this is equivalent to the Ampere's law. So just now, I want to mention that we will learn the second law in the Maxwell equation called the Ampere's law. Okay, and actually this one is equivalent to, is compatible to the Ampere's law. Just like in chapter 23, we also showed that the Coulomb's law is compatible to the Gauss law. Okay, so yeah, so here we have for a long straight wire carrying a current I, so the Biot-Savart law gives for the magnitude of the B field at the perpendicular distance r from the wire, B to be mu 0 I over 2 pi r. So yeah, this one is easy to remember. OK， 所以通常我都记起来，因为其实这个式子出现的是会在这1-2章里面一直出现哈，这个是出现几十万次的。OK， 所以这个意思是我们有一个很长的直的一个导线，有一个 current I， 那直的很好理解，直的就是不是弯的嘛，那长的多长？长的话就是无限长infinitely long straight wire. So here just it is just expressed as this as this dot, okay, with a cross, okay. So which means that the current is going into the page, Okay, so in that case, according to this statement, it says that this current, this long straight wire, okay, 就是说它这根线是直的，而且是无限长的，所以在这个图里面它是我们只看到一点，但是它是往里面到无限远，往外面也到无限远的，所以是一根无限长的线。那然后有一个电流有一个固定的电流 I 的话，它就会产生一个 B field， 在整个空间里面产生 B field。So the magnitude of this B field is mu 0 I over 2 pi r. Okay, mu 0 is 4 pi times 10 to the negative 7, and then this is also a constant. So this is a current. Okay, so this B field is proportional to the current, and then inversely proportional to the distance. Okay, so this is the distance, the perpendicular distance, 垂直距离啦，就是在这个空间里面随便点一点，比如说我们有这个是那个导线，有一个点在这里，那你就做一个垂直线交到这个点，那这个距离就是那个垂直的距离。那 okay, so for example, this point you take you draw a line, okay, connecting to them, okay, and then this is perpendicular to this line, and so this is the distance. This is the distance. Okay, so mu 0 I over 2 pi r. Okay, actually I will show the proof of this formula in the next page. And likewise for the semi-infinite straight wire, 就是这只有一半的，就是正的方向有，或另外一个方向没有，或者是反过来也行，反正两边所产生的是一样的。So the magnitude of the magnetic field at the perpendicular distance out from the wire will be half of it. Okay, so it is. We will also prove it in the next slide, or maybe we will just assume it to be like that in the coming slide. Okay, so here we try to integrate this stuff. So here we have a wire, okay, like this. Okay, so actually go to the infinitely far away, and here the current is from bottom to top. Okay, here we try to take this is the 0 point for the ds. Okay, so this is the s-axis. This is the s-axis. Okay, so for this point, this is ds or ids, and this direction will be the r. Okay, so we just consider, because this line is infinitely long, so we can always consider this p is aligned to the 0 point. 就是它是无限长的，所以你这个点高一点低一点，其实我对过来我还是可以把它看成是零这一点，因为它上面是无穷大，下面也是无穷大。Okay, so in that case, this is S, this is ds, and this is R, or this is R hat. Okay, so in such a way, we can have a ds cross R hat. ds cross R hat will be pointing into the page. So we have dB going into the page. Okay, so B will be 2 times C integration. Okay, so maybe starting from here, the law of Biot-Savart is dB mu 0 over 4 pi I ds sine of theta R squared over R squared, like this. Actually, the B should be like integration of dB from negative infinity to infinity. Okay, but you can easily find that. Okay, suppose you find a symmetrical point. So this is ds prime. This is ds prime. Okay, so and this is actually the same R. Okay, so you can actually verify that. Okay, so this is 180 degree minus pi theta, or maybe pi minus theta. Okay, so in that case, sine of theta and sine of pi minus theta will be the same. And this one r square is the same, I is the same, ds also be the same. So you can easily verify that for this part generate dB here, or ds prime generate dB prime here will be the same. So in that way, we only need to integrate from 0 to infinity for the dB, and then multiply by 2 will be the full B field generated by the whole wire. Okay, so here we just plug in this one to here. So these 2 and 4 partly cancel, become 2 pi. Mu 0 I is a constant. And then ds sine theta putting inside, and then r square putting inside. Okay, so here the dummy variable for the integration is ds, but this is r square. We cannot directly integrate, and also we have this theta. So we try to change some variable to make all the things to be expressed by single variable s. Okay, so this for this r, okay, in this right angle triangle, so according to the Pythagorean theorem, r is square root of s squared plus capital R squared, like this. Okay, according to Pythagorean theorem. And then sine of theta and sine of pi minus theta will be the same. So sine of theta, so this is sine of theta, this is sine of pi minus theta. Okay, so it is actually r over small r. R over small r will be r over square root of this stuff. Okay, so here we can put r and sine theta to be like this and like this to here and also here. Okay, so r square, okay, take the square, will be like to the first power, and then sine of theta here will be this one. Okay, so we have r over a square root. Okay, so altogether we have a 1.5 order, 1.5 order for this stuff. Okay, so for this one, it is yeah, it is something like this. Okay, I don't try to go through the process. Actually, you need to do some change of variable because this one, for this one, you probably need to assume s to be r tangent of phi, something like this, and then you plug in and then do some change of variable, and which means that ds equals r secant square phi d phi, something like this. You do some stuff, and then finally you can find the antiderivative like this. And then we try to evaluate from 0 to infinity. So plugging s to be 0 will be 0. Plugging s to be infinity, so this one will be nothing but a 1. Okay, putting it to be s to be infinity. Okay, so if s is infinity, this r square can be ignored. So s square, take the square root, will be s. So s and s over s will be 1. So finally it becomes b to be mu 0 I over 2 pi r. Okay, any questions?